Ever wondered how to trace the route of your data packets in Windows and Linux? Imagine each data packet as a tiny digital postman darting across the vast internet, delivering your messages. Knowing their journey is key to understanding the speed and efficiency of your network. It's like being able to peek into the secret pathways of the internet. Intriguing, isn't it? Now, let's delve into the fascinating world of data packet tracing. In the world of operating systems, two major players dominate the scene: Windows and Linux. Each boasts its own set of unique tools and commands, and today we're diving into two of them: Traceroute for Linux and Tracert for Windows. Both these commands map the journey that data packets take from your computer to a destination server. It's like your personal GPS for data, showing you each stop it makes along its route. However, even though they serve the same purpose, there are some differences. For one, the syntax and output of these commands can vary. In Linux, you would use Traceroute, followed by the destination IP address or hostname. On the other hand, in Windows, it's Tracert, followed by the destination. Now that we know what these commands are, let's explore how they work. Syntax: the set of rules that dictate how programs in a specific language are to be written. It's crucial to understand the syntax when using these commands. Let's dive into the syntax for Tracert in Windows and Traceroute in Linux. We'll use a side-by-side comparison to highlight their differences and similarities. Starting with Windows, the syntax for Tracert is quite simple. You begin with the command Tracert, followed by the target's IP address or domain name. For instance, tracert www.example.com. This command traces the route that packets take from your machine to the target destination. Now, let's switch gears to Linux. The syntax for Traceroute is slightly different, but still straightforward. You begin with the command Traceroute, followed by the destination's IP address or domain name. For example, traceroute www.example.com. Like Tracert, this command also traces the route that packets take from your machine to the target destination. However, both commands offer additional options for more detailed information. In Windows, you can add D to prevent Tracert from resolving addresses to host names, making the process faster. In Linux, you can add N to Traceroute for the same effect. While the basic syntax is quite similar, there are some key differences in the advanced options. For instance, in Windows, you can define the maximum number of hops with hmax hops, whereas in Linux, you use mmax hops. Furthermore, to specify a particular interface in Windows, you use jhostlist, whereas in Linux, you use iiface. Also, to change the initial time to live (TTL) in Windows, you use ittl, whereas in Linux, you use ffirst_TTL. In summary, while the basic syntax of Tracert and Traceroute is similar, the advanced options vary significantly. It's essential to understand these differences to effectively use these commands in their respective operating systems. With the syntax cleared up, it's time to explore how these commands work in action. Now, let's put theory into practice and see these commands in action. We're going to kick things off with the Windows operating system. To execute the Tracert command, we simply open the command prompt and type Tracert, followed by the domain name or IP address you wish to trace. For instance, tracertexample.com, press enter, and the magic begins. The command works by sending packets of data along the specified route, logging the time it takes for them to reach each hop along the way. The output displays each hop's IP address, along with 3 round-trip times in milliseconds. Now let's switch gears to Linux. The process is quite similar, but we'll be using the Traceroute command instead. Open your terminal, type Traceroute, followed by your target domain or IP, for instance, tracerouteexample.com, and then hit enter. The Traceroute command outputs a list of all the routers it passes through until it reaches its destination, or fails to and is discarded. Each hop is identified by at least one IP address, although it can be followed by a domain name if available. At first glance, the outputs of Tracert and Traceroute might seem identical. Both display the route a packet takes to reach a specific destination. However, a closer look reveals slight differences. For instance, Traceroute on Linux uses User Datagram Protocol or UDP by default, while Tracert on Windows uses Internet Control Message Protocol or ICMP. This can sometimes lead to differing results due to various network policies and configurations. Also, the way the two commands measure time can differ. On Windows, Tracert shows the time taken for a round trip from your machine to each hop in milliseconds. On the other hand, Linux's Traceroute shows the time taken to move from one hop to the next, giving a more granular view of where possible delays might occur. Just like that, you've traced the path of your data packet. Quite interesting, isn't it? So, what have we learned today? We've taken a deep dive into the world of data packets, examining the role of Traceroute in Linux and Tracert in Windows. We've dissected their syntax, revealing the nuts and bolts of these powerful commands. We've seen them in action, showcasing their ability to trace the journey of data packets across the network. We've decoded their output, providing you a roadmap to interpret the data they present. And there you have it, a simple way to trace the journey of your data packets in Windows and Linux.